Greetings, polyethylene fans. Peter Dyke here. Welcome to 2026. We're delighted to bring to you our second podcast of the year. And sitting to my right, so to speak, is my good friend, Dan Landy. Welcome, Dan.
Hey, Pete. Happy New Year. Ready to get back into things? I think we're on podcast taping number 40.
We are. So this will be the 40th. And as we said in our last podcast, Dan, we're committed to doing one per month this year. So we're starting the year off right. And this is our second podcast of the year.
Yeah, new interesting content. Data centers. I'm not sure. A couple of years ago, I would have thought this would be a conversation piece, but it's a new year, so we kind of never know what we're going to get into. The industry kind of tells us what's important, and it's our job to listen.
Yeah, so that's true. But before we get into that, I kind of want to hear from you. What's on your radar for this year? You know, Dan, we put together a pretty healthy schedule. The schedule is already packed all the way through the end of October. But other than producing these webinars, the podcasts, the trade shows, the seminars, the road shows, what's on your radar?
Yeah, so as a very healthy trade organization, we do have a lot of member input. And at the new year, I always kind of like to reset and think about what's going to be different this year, what's good, what are we keeping, what are we changing. And at the new year, I like to kind of set and start fresh with training. So if you didn't get trained in 2025, your qualifications are looking at rolling over at some point in this year, putting a plan together on what your training program is going to look like. So there is manufacturer training, there is distributor training, and it's really blossomed in the last few years. It's way more available than it's ever been.
Well, to your point, George Fisher originally on the electrofusion side pioneered training, but you all had to go to Shawnee, Oklahoma to get your training. Then Integrity with Rick Ponder came out several years ago with their online training program. So you can actually get level 2 training online from Integrity, which is extraordinary. So they do a combination of a Zoom call. I don't know if they use Zoom or not, but Zoom calls. And then you actually do a fusion, Dan. Mm-hmm. You send it to Peachtree City, Georgia, and they evaluate your electrofusion for you.
Yeah, I've done all three now. I've done George Fisher and Shawnee. I've done Integrity both in person and online, and I've done Strongbridges. So I might be the most educated person that'll never do an infield electrofusion in my life.
Yeah, so now Strongbridge is doing it as well. So between those three electrofusion providers in the United States and Canada, we are well covered. And as you and I know, some of our distributors only use Strongbridge, some of them only use Integrity. Most everybody uses George Fisher. So now it's because it's so available, we're not electrofusion training constrained like we used to be. So hats off to our members, Dan.
Yeah, and the one reason I like to bring up this training is because if you're an end user, a contractor, you might not be aware of this, but most of the electrofusion manufacturers, they're not going to sell you a large diameter fitting unless you've been trained by them or what they consider an equal. So, if George Fisher trains somebody and Strongbridge wants to, sell the contractor a couple of years down the line, they will sell to them, but they do want you to have an up-to-date manufacturer qualification. So it is good, just start the year with, planning on what you're doing on that polyethylene training end.
Yeah, so that's electrofusion. Then, of course, on the butt fusion side, McIlroy has pioneered butt fusion training out of Tulsa. So I love the fact that you're encouraging our listeners to make sure their teams are properly trained, Dan, because that does come up as an issue from time to time.
Yeah, I mean, you can get if you have a good relationship with your distributor, you could probably get trained this weekend. I mean, we're recording this on a Friday. You could probably, if you were in a pinch, get someone to come out Saturday or Sunday. Within a week, training should not be an issue. Electrofusion requires a little bit more planning and processing. If you guys want to get what are the people that observe the job site? Inspectors. If you want to get them trained, that's really available. That's online through McIlroy, 100% online. It takes about 3 to 4 days. But so it is important to have a plan because some things take longer than others.
All right, well, let's get to business. So when you and I went to Infusion this year, which is McIlroy's big annual event that usually occurs in October every year, one of their key messages was, hey, guys, I hope you're paying attention to data centers. So because we learned quite a bit about data centers then, and of course, Dan, we've been hearing about data centers for years now, particularly with the hyperscalers, those big companies that are building out these data centers. But now McIlroy's really put it on the forefront, and they have asked Andy to spend a fair amount of time studying it and getting into this market. So with that, let's bring Andy McIlroy on screen. Welcome, Andy McIlroy.
Thanks, Peter. Thanks, Dan, for having me. Happy to be here.
So who is Andy McIlroy, and what do you do, Andy?
Well, as you have said earlier, my focus at McIlroy Manufacturing is on the data center world, mission critical, if you will. So both data centers, chip fabs, and things of that sort. I've been with McIlroy for all of my life, as you might have suspected with the last name, but I've been working for the business for the last 2.5 years with my sole focus on these emerging markets, these booming markets, if you will.
Wow. Well, that's quite a responsibility. For there are some people in the audience that are listening that are only tangentially involved in the polyethylene and polypropylene industries. Tell us who McIlroy is and what they do.
Yeah, absolutely. So McIlroy Manufacturing is the leading manufacturer of fusion equipment worldwide. So we make equipment that fuses thermoplastic pipes, primarily HDPE and polypropylene products, and anything from 1/2 inch all the way up to 2,000 millimeters, which if my metric brain is working, is about 78 inches. So a wide range of fusion equipment is available from McIlroy.
Yeah, I'll say. And they've been a big supporter of the Alliance. And in fact, your colleague, Dave Hughes, was in the room when the Alliance was started back in 2008. So we appreciate that support. So Dan and I went to Infusion this year, Andy, and you guys were talking a lot about data centers. Tell me, what's the interest? Why do you care so much about what's going on in the data center world? I mean, you're going to get a certain amount of plastic pipe sales and fusion sales as a result. But anyway, tell us a
Yeah.
little bit about your interest.
Yeah, absolutely. It's a great question. And, it's not been our traditional go-to-market strategy. We have really tried to get in front of this one. So data centers, we realized through our connection with the heat exchanger world, one of other McIlroy products is fin tubes. So basically a very necessary component in heat exchangers. And we saw that industry was ramping up for the data centers, and that there was likely a really, really good path for fusibles within data centers. And, we've always believed that if we want to expand into a new market, we're going to have to be the one to, help push that forward alongside our distributors. And the reason data centers is so interesting to McIlroy on the fusion side of things is the amount of pipe that are going into these facilities is astronomical. Like no other construction projects that we've seen before from a volume of pipe. And given the direction of technology within these data centers, the fusible solution is an incredible fit. Moving from the legacy metallic materials as direct to chip cooling or liquid to chip cooling, as you may have heard it. They're not able to use the traditional metallic carbon steels. And so they're really left with two options, which are stainless steel, which is where they initially went and still is the primary material of choice, and fusible. So polypropylene RCT. And then we've also seen just an absolute explosion of demand for HDPE on the underground side as well.
Wow. So when you say fusible, you're talking about both polyethylene and PPR-CT.
That is correct. Yeah. Yeah. And generally, when we talk HDPE, polyethylene, we're generally talking about underground. Although we have seen some of that come up out of the ground in the way of, well, just plain HDPE, and then also PERT for the raised temperature. And then the PPR-CT we've seen primarily used in the mechanical systems throughout the facility.
All right. We've talked about three pipe types already. We've talked about HDPE, which is high density polyethylene. What is PPR-CT?
Yeah, so this one is a bit of a mouthful. So PPR-CT stands for polypropylene random copolymer with modified crystallinity and temperature resistance. You will not hear me say that again on the podcast, but that is what it is. And what that means is we take the legacy material, which is PPR, polypropylene random, and we've added, not we McIlroy, but the industry as a whole has added a fiberglass layer in the center, which allows the pipe to have better thermal
Performance. Yeah.
characteristics similar to what you would generally see in mechanical systems like copper and steel. So that crystalline layer allows it to be more rigid and fit better in areas that historically have been copper or stainless steel.
When you're talking to these end users, are you talking to the owners when you're out in the market, or are you talking to the contractors?
So it's a little bit of all of the above. Our initial strategy was to essentially go build relationship with hyperscaler companies. So just think big tech companies that, you might look something up online with their platform or buy something that's going to get delivered to you. Build those relationships. And we took a PE Alliance-esque approach, which was let's educate them on what this technology is, why it is such a good fit for what they're doing. And then lastly, how to implement it with some of our tools like the data logger and the automation that we have within our I-Series ranges.
So Andy, not to take a half a step back, but
Please.
we're fresh off the Christmas holidays, and a lot of times I notice that me talking to my uncles, that the boomer generation, they hear buzzwords, and the buzzwords have changed over time.
Yeah.
So data centers to me for the longest time meant data safety, data storage, data processing, and now the reason for this gold rush is really AI, right? I mean, this is the boom we're seeing right now.
Yeah, so AI is absolutely a primary contributor to this growth in the industry. But to clarify on, kind of what is a data center, there is over the last, I don't know, 15 years, the cloud has been, the buzzword of where you store things. And the funny thing is the cloud is not in space. It is not, invisible. It's just a data center that's located somewhere else, as opposed to, you know, um, previously you might have had a small data center server rack in your business's facility. And instead we're using internet to get your information to be stored elsewhere at a data center remotely. Um, and then, you know, that's the backbone of where data centers came from and, the steady growth. The AI that you mentioned is the catalyst for, this, you know, arms race for AI, if you will.
So it's really database storage and AI technologies.
Exactly.
Okay. Yeah, I forgot about the database storage. That's interesting.
So
Yeah, absolutely.
your pitch to these hyperscalers and other independent builders, real estate people associated with the construction of these facilities is what? Why is polyethylene better than carbon steel and stainless?
Absolutely. Great question. So there's a handful of reasons. The first is it is cost effective to install, especially as these systems have moved to stainless steel. We're seeing, roughly 20% cost savings from a material and install standpoint. Number two is the cleanliness aspect. I mentioned that there's no scaling or corrosion that happens within these systems. As we go liquid to chip, we have to have that cleanliness. And we have a great use case that when we approach these, hyperscaler companies, we've got a great track record in the semiconductor fab facilities. Almost all of the systems inside of those high-tech buildings that are actually making these microchips is done in fusible technology that they've been using, for decades.
But a lot of the consulting civils that are doing this inside the building design work and the site plan the site development are typical civils that may
Yep.
or may not know about those fab chip factories that polyethylene and polypropylene have been involved in. Is that correct?
You're exactly right. Yes. And so our top-down approach is from our go-to-market strategy is let's educate the people that they do have high demands. They are very particular and oftentimes are designing certain parts of their systems in-house before they even bring those major engineering firms in. And so we're going to educate from the top down, simultaneously supporting our distributors in educating from the bottom up as well.
Got it. Okay, so no scaling, less cost, and we have a tremendous track record.
Yeah. And, some of the other advantages include the weight. It is 80% less or 80% less weight if you use a fusible system versus stainless steel. And the reason that's important is, these facilities average 1 million square feet today, and they are trying to figure out ways to future-proof because of how fast things change. If they're able to save weight in an area like piping, which is a considerable amount of load, that gives them flexibility in how that facility can be used in the future as needs change.
Wow, exciting. So I see the opportunity. So Andy, you said something that I find pretty interesting. Dan and I worked on this job in Randall County, South Dakota, and it was 70 miles of 30-inch DR11 to 17.
Yeah.
And this municipal entity is taking water from the Missouri River and bringing it to Mitchell, South Dakota. And we're all excited about a 70-mile job. And we should be. It's a big deal.
Absolutely.
And it's a lot of pounds of polyethylene resin. How many miles and how many pounds? What are we talking about in one of these typical 1 million square foot buildings that you're talking about?
It's a great question. And, I like to pose and ask the question, what do you think it is, Dan? How many miles would you expect in 1 million square foot facility?
Okay, so this question always trips me up because the breakdown from larger pipes to smaller pipes.
Sure.
So putting it all together, I would say one large data center is about 7 miles.
I would love to say it's a good guess.
Andy, he obviously didn't attend the session we did at Showcase this year.
Exactly. So what we've seen, and this is just talking the mechanical system, so not the underground scope at all, an average of 6 linear feet for every 10 square feet of space. What that equates to in a 1 million square foot facility is about 115 miles of pipe.
Wow.
And, to give you an idea, I think there was 39 hyperscale data center projects announced last year. 28 of them are under construction. And some of them, one of the notable ones, Stargate in Abilene, Texas, is expected to span 8 million square feet. So, 800 plus miles of pipe in that one facility.
Were we successful in getting polyethylene and polypropylene into Stargate?
I can speak to the HDPE and know that there is a considerable amount of HDPE being put in the ground for that project.
Well, we have been successful at Tesla in Texas. We were involved down in Austin when they built that 2 million square foot facility. So it's not...
and
go ahead.
And, regardless of your opinion on Elon Musk, he has taken a fusible approach in almost every one of his businesses. I forget the name of Colossus that's in Memphis. That facility is 100% fusible pipe. And the other unique thing about how he runs his companies is he's very public about what's happening in there. There is video of 36-inch HDPE running inside that building, delivering chilled water to direct-to-chip cooling systems.
Yeah, and Andy, the whole data center and the Tesla thing, the Google, all these big tech companies, it really highlights two major talking points that I'd like to talk about in our roadshow program. One is, and I wish I had more data on this, but the longer a system has been around, the more likely it is ductile iron or PVC. The newer a technology, there's like a 100% direct correlation of HDPE's market share. And that goes into something that I call bad habits. It's when these industries don't have bad habits to fall back on, they're like looking at it with a clear lens. What's the best solution for me?
Yeah.
And between that and private ownership, I think the private ownership has a lot to do with it too, because they're the ones paying these electric bills. And everyone knows on AI, the electric bill is the real kicker in those technologies. Same for data centers, same for data warehouses. So, a more efficient piping system, they're saving a whole lot of money.
Absolutely. And they can't afford to have leaks in these places. We're talking a singular row of servers could be $100 million with liquid flowing on top of it. And I think the great thing about where we are today in the industry is that, these private companies, as you mentioned, are data driven, at their core. They're looking at what is the best solution, not what is the solution that we've been using. And that has been I think, a huge driver for the increased use of fusibles in these facilities.
It's pretty exciting listening to you guys talking. For these data centers, we need water, land, and electricity. And polyethylene pipe and PPR-CT, and we're involved in all three.
Yeah.
We just gave an award to a project that we were polyethylene conduit. Well, Andy, it's the same PE 4710, but it's conduit instead of carrying water, and they're using fusion.
Yeah.
And these fusible systems are in the ground, preserving that resource, whether it's electricity or water or sewer or natural gas. So, what an exciting proposition we have. So
It really is. And if I could say one thing, the conduit is a great example too. I mean, I think when people generally think conduit, they think of a small diameter roll sitting on the side of the road for, electrical. But what we've seen in these, electric intensive projects like data centers, like chip fabs, is these conduits are getting significantly larger, and filled with massive amounts of electrical components. So, you were right. We're seeing it on all fronts, really.
So as you look at this, and I look at it, I'm interested in your perspective. So when people ask me, well, Peter, what's our market share in municipal water in the United States? Well, it's 12%. We've come at it a couple different ways, but 12% of all the pipe going in the ground today in municipal water, wastewater, transmission, service lines is HDPE.
Yep.
How successful? So your benchmark is 12%, because we're talking to the same group of people, generally speaking, if we're looking at the consulting civil cohort. How well do you think we're doing in the data center market?
On the underground side, this is just a guess. I don't have exact numbers. On the underground scope of work, I think we are double, if not triple, that 12%. So a significant level of, adoption. On the inside of the building, I think we probably live closer to that 12 to 15%. There still are systems that don't need the qualities of cleanliness as much, and so you can still use carbon steel in a cost-effective way. And then on the critical systems, I think it is back to Dan's point about the way we've always done it. Change is hard, and so they've just continued forward with stainless, but we are picking away at that for sure.
So are you able, with all these NDAs that I hear about, I mean, I have trouble getting people to even talk about data centers. Peter, I can't talk about it. I mean, they just sold the biggest job of their life and they can't talk about it. Are you finding that that's true with your work? I mean, can we write more case studies to let these people know that it's happening? I mean, Colossus is a huge win for us. I mean, Memphis is a huge win for polyethylene. I can't get anybody to tell me about it.
Yeah. The NDAs are funny, in my opinion. They absolutely are a thing. I can speak in general terms because I've, worked on so many different projects. I'm not exposing any one necessarily that isn't public already. I do think it will continue to be hard to get real hard case studies published with names because these companies so tightly they keep their secrets so close that they don't want to necessarily help their competitors.
Yeah, that makes sense.
It has been a frustrating thing, but it is what it is.
Yeah.
Yeah, these are publicly traded companies, right? For the most part,
They are.
that the more information, yeah, they don't like getting that out there, I'm sure.
Yeah.
Is there anything in the mixtures they're using? I assume it's some type of glycol for the most part.
Yeah. The primary cooling liquid for direct-to-chip is a PG25, so propylene glycol, a 25% mixture. And then on the chilled water, it's just standard chilled water.
So we're taking the heat that's generated in these vertical banks of computers.
Yep.
And what are we doing with that warmer water, and how hot is it?
It's a great question, and timely too, after the announcement this week at CES from NVIDIA. Up until this week, the warmest liquid, and we'd call it hot, I guess, at this point, coming off of a chip is about 130 degrees Fahrenheit. And so what happens is you really have two cooling systems in these data halls. You have direct to chip, which is taking about 80% of the heat load away from the chip via what's called a cold plate, which is really just a metal plate with very small capillaries that this PG25 flows through. Once it leaves that chip, it comes in at maybe 100 degrees and it leaves the chip at 130, and it goes to what's called a coolant distribution unit, which is just a fancy way of saying a heat exchanger that then basically transfers that heat back to the air and puts it into what's called a hot contained aisle, where that will be cooled in a traditional air format.
So they're putting 100-degree water on there, and they call that cool?
They are, yeah. And the NVIDIA announcement was that they will have chips running up to 200 degrees. The water coming off of them will be 200 degrees on the next generation of NVIDIA chip.
What's that do for us?
Well, the upside of fusible pipes is we can extrude thicker wall thicknesses. So, today I'd say the standard in a data hall, depending on your pressures, is going to be SDR11. I've seen a decent amount of SDR9 coming. And then, if you go look at the pipe manufacturers' temperature and flow or pressure ratings, we can get there still. It's not out of reach. I will be interested to, watch where that trend goes, how much hotter it goes, before they have to go to probably an immersion solution.
So for our listeners that really aren't that experienced with temperature and polyethylene, our limits are 140 Fahrenheit
Yep.
with traditional HDPE 4710. Then we have another product on the polyethylene side, which is called HDPE-RT, or raised temperature. That's a Dow
Yep.
product. And that goes up to what, 180?
Yep.
Yeah.
I believe that's correct.
And then that's why this PPR-CT is such a wonderful product, because it gets us up even above that to currently what temperature, Andy?
So I believe it depends, once again, at zero pressure and an SDR 5, I believe they can get to the mid 200s.
Wow. So here you see in this application, unlike in municipal water and wastewater, we have an application where we really need that temperature, that pipe to be able to carry a very hot liquid. So
Yep.
What a unique application this is. And I'm so glad that polyethylene, polypropylene, and the raised temperature product is acceptable and being used.
Yeah, absolutely. And the use case between PE and PPR-CT is super. It's very symbiotic. The polyethylenes have primarily been used and are continue to be used on the chilled water loops, which aren't going to be at that high of a temperature. They are they are removing heat that's already been removed by the CDU. And so, you're still able to be within the thresholds of those materials for the applications that they're generally being considered for.
Got it. Well, I hope we got a bunch of civil engineers and mechanicals listening to this because you're a wealth of information. I've got another question for you, Andy, and it goes to the whole issue of, here I said 12%, you're saying 2 to 3 times that. What impact do you think plastic's role in the rollout of these data centers is going to have long-term on the municipal water market?
It's a great question, and it's the one I'm most excited about today. I think that what's happening with data centers and fusible technology is awesome right now, and we should ride the wave that is this, AI arms race. Um, what I see happening is these hyperscale companies coming into municipalities that desperately want them to build there, and they come, these hyperscalers come and say, well, we use HDPE for our, water delivery, whether that's forced water, chilled water, processed water, wastewater. We use HDPE, and the city might come and say, well, that's not in our spec. And never before have these projects had the leverage, this is my opinion, had this leverage to get cities to agree to a new material into their spec. And my belief is that as more of these cities and engineering firms and contractors get exposed to fusible in these underground water markets, the next large scale water projects in these municipalities, in these rural water districts, whatever it may be, they're going to go, well, hey, hyperscaler XYZ insisted of using HDPE and we're about to use ductile iron or mechanically restrained PVC. What do they know that we don't? Maybe we should be doing that too. And I think it's going to usher in, a massive change in materials for, municipal water.
Yeah, exciting stuff. You know, we've talked a lot about pipe and its application. I mean, here you've had a chance to talk about equipment. I mean, you guys are in the equipment business. So I assume you're making mechanical equipment that fuses this PPR-CT. Tell us about the kind of equipment that's being used to fuse up these pipes.
Yeah, absolutely. It's a great question. And, McIlroy has been making a mechanical focused equipment for the better part of 15 years. We've been making fusion equipment for over 50. And, the needs of the mechanical market are different than, the pipelining of underground systems. And so we've developed a suite of tools that, range, like I said, from half-inch all the way up to 630 millimeter on the mechanical side of things. And these equipment don't look terribly different from our PE side of things. They're generally have smaller jaws, lighter weight for getting up in the rafters when you need to make that final connection. And then I think the biggest change that we've seen, and I think other markets are seeing it as well, it's the prefabrication of assemblies to make on-site construction faster. And we're absolutely seeing that in the mechanical market today more than we ever have. And so what McIlroy has realized is that automation is key. So productivity in these fabrication facilities is priority number one. And so we have launched two new products in the last year that are really focused on meeting that need of automation in a fabrication facility. That is the Acrobat I-Series. You might recognize, if you're familiar with our equipment, from the Trackstar I-Series. So this is a fully automated fusion machine that is focused on the mechanical market. And then the second is the ProFab 400i, which is a two-jaw machine. It's meant to stay stationary in a facility and has the ability to do miters. So, if you don't have a fitting, you can make one yourself. And once again, this is a fully automated piece of equipment.
So I assume you're rolling these out to your channel partners, your distributors that are selling your products.
Absolutely, we are.
And just to repeat what you said, so like what we see in the municipal water market, if you can draw it on a napkin, our distributors can fabricate it and send it to a job site. You guys are encouraging your distributors to make these prefabricated spools that end up on the job site ahead of time.
Yeah, and it might be our distributors, it might be their customers too. So we've had an increase in mechanical contractors coming to us saying, "Hey, we won this job. They're doing it in PPR-CT. We need help putting together a facility. Can you help us understand what it should look like, how it should flow, so that we can, produce this massive volume of systems that they've been asked to do."
Yeah, think about it, 100 miles of pipe in 1 million square foot building. I mean, that's extraordinary.
It is.
Wow. You also mentioned one time so far about the data logger. The I-Series runs on the data logger. I assume your new mechanicals. What role does the data logger play? I'm very familiar with the municipal water, but what role does it play here?
Yeah, it's a great question. And I'll revert back to when I was talking about our approach with the hyperscalers and our strategy with them, and the data logger is at the core of that. Like I mentioned, they are data-driven companies. A lot of this work, as we've mentioned, is happening off-site, out of sight of the inspectors oftentimes. And so what the data logger does is give the owners or the engineers or the contractors visibility into what's happening at all of these facilities, and the ability to be notified if a joint was not done properly. And then they're also using it as a tracking. How far along are we? How many joints are we doing? Where are we on progress with certain spool pieces? And one of the other innovations that we've rolled out this year is called the Vault ID tags. So these are, I'm not supposed to say stickers, but they are stickers that go onto the pipe after a joint's been made. And when you take a picture of the QR code on that Vault ID tag, it automatically connects it to that joint report. And so when a spool goes out that maybe consists of 50 different fusions, you can very quickly get to all of the data that these joints were done, who they were done by, when they were done, and that they were done properly.
Yeah, I hope you roll that out to my industry.
Hey, they will work in any industry. The mechanical industry was the one that was asking for them. So they've been incredibly well received so far.
Oh yeah, what a cool idea. Dan Landy, what else do you have for my good friend Andy McIlroy?
No, I just appreciate the opportunity of being able to learn a little bit more about that. Getting questions about it a little bit, but it's still kind of not exactly my strength. So it's just really good to learn from you guys, and good to hear that we're ahead of it. I think that was kind of the concern a few years ago, was how do we get ahead of all of this? So I'm glad you guys have taken that role, because it's not an easy technology to understand and be able to influence.
Yeah, absolutely. And
anything else you'd like? Go ahead. Anything else?
Yeah, I was just going to say, my role at McIlroy is, I want to help our industry grow, and the offer I make to all of our distributors, all of our partners and reps and pipe companies is, I'm here as a resource for the industry, and really want to be an open book to help our market grow as quickly as it can, and as painlessly as we can, because what you don't know can get in the way of progress.
Yeah, that's for sure. Well, what a fantastic learning hour this has been. Andy McIlroy, McIlroy Manufacturing, thank you so much for joining us on the Poly Podcast. And with that, we'll call it a day. Stay tuned as we build out our program for this year. If you have any ideas that you'd like to ask us to consider for the podcast, send them along to pdyke@pepipe.org, or Dan Landy at dlandy@pepipe.org. And with that, we'll sign off and give a heartfelt thank you to Andy McIlroy from McIlroy Manufacturing.
Thank you, Peter. Thank you, Dan. Appreciated being here today.
All right. So long for now.